Hello everyone, this is going to be an explanation for day 16. I was out on a trip, so I didn't get to record this, but I'm just doing this just to have a complete set of 2024. So this puzzle, we are at the Reindeer Olympics, and so we need to find the best path in a maze, given that each turn that we do costs 1,000 points. And so if we look here, if we look at this maze, it will cost us 1148, which essentially means that we did 11 turns and it took us 48 steps to get there. And so with our input, which is a bit larger, the best way to do this obviously is to use Dijkstra's algorithm. And so that requires a min heap and then going through all the nodes. And then to make it easier, you can also, I chose to pre-process each step of the way. So instead of using the grid itself, I just used a different key, which keeps in track of the previous direction. And that way we can easily attach the correct weight. So if we need to move forward, we only add a score of 1. If we need to rotate, we add a score of 1,000. And then we also do a special case for the end, because as soon as you reach the end, you don't need to worry about turning to get to the right one. And this makes it super easy because all you got to do is run Dijkstra's, and then we just find whatever the end is. So for part 2, we need to find how many nodes are on the best path. And so there's multiple possible best paths, and so how do we find that? So one way, and the way I did it, is to generate both distances from the start and to the end. And so because we know the best paths score from part 1, we can use that to find what all targets belong on the best path. And so to do that, we use, if the position that we're searching for has, when you combine the weights from each side, has the same target weight as the best one, then we must know that it is on the path regardless of what path it is. And so this took me a while, and I honestly had to get some help from the mega thread to find this. But I tried using Dijkstra's just to get all the paths, but it wouldn't run in time, which is understandable. But this one runs in pretty decent time. Both run really quickly, and so I'm pretty happy with it. So yeah, that is day 16. So yeah, thank you.